the answer to the first one? 0. Second one.
Infinity, positive infinity.
There you go. You should know that. You should know that offhand about the exponential function. Okay? There is an inverse function to the exponential. It's called the logarithmic function. And for this particular exponential function, it is the natural logarithm. It looks something like this. And it has a vertical asymptote. These pictures are simply reflections about the y equals x line, right? If you flip that over, your vertical asymptote will become horizontal, and your curve will be going this way then. It makes an inverse. So now, if we took ln x, limit of ln x as x goes towards negative infinity, there's nothing to say. It doesn't go towards negative infinity. You can't even ask that question. So all I can say is, what's happening to it as it goes towards 0 from the right? Okay. What is the limit of ln x as x goes towards infinity? Those are the two you want to worry about for this function. The answer to the first one is clearly negative infinity. Right? And the second one is what? Infinity, that's right. It does not taper off. Right? It's usually going up forever very slowly, which is its great property. It rises very slowly. One more. Very general. Let p of x be a polynomial. Limit of that function as x goes towards infinity has two options. What are the two options? Positive or negative infinity, that's it. Right? No polynomial ever has horizontal asymptotes. Or vertical. Right? No such thing for polynomials. So any polynomial, as you go out towards infinity, is either going to go up forever or down forever. It's one or the other. And so too when you go towards negative infinity. So the limits at infinity for polynomials are always infinite. One or the other. Right?
The limits are always infinite.
For polynomials, yeah. Limits at infinity are infinitely large for every polynomial. How do you know which direction it is, though, just based on the function? Let's say p of x. Let's say p of x was x cubed minus 4x squared plus 8x minus 5. Let's say that was your polynomial. And I ask you the first one. What is the limit of this polynomial at infinity? What's it heading towards as you go out to the right, very far in the graph? So you go out very far to the right. Is this polynomial going up forever or down forever?
Up.
How do you know?
Because it's cubed.
Does the end behavior tell you?
Say again?
Does the end behavior tell you?
The end behavior is whether it goes up or down.
So in the end behavior depends on the negative 5, right?
End behavior depends on
the three.
the exact. It actually depends on this guy alone. It depends only on the leading term, right? It's only leading term, always leading term.
Since it's an odd number, does that mean it's going the opposite?
Not necessarily. The fact that it's odd has relevance when you're going the other direction. But right now, just think about it. X is becoming infinitely large. So now you put it inside this x cubed. What is x cubed doing? Becoming infinitely large or infinitely negative?
It depends on x.
But well, x is going towards positive infinity. X is heading out that way.
Oh, there's beginning large.
That's right. So that's why this answer should be positive infinity for this one, right? Well, basically, all you have to do is think about what is the leading term doing? What's x doing in the leading term? Well, it's becoming as large as possible, and I'm just cubing a super large number, so it gets even larger, right? I'm cubing a positively large number, so it maintains its positive largeness, right? So heading towards infinity. What about if I make it negative? Well, now, in the leading term, the x cubed, that part itself is still positive, but then I multiply by -1, it makes it negative. It's heading downwards now, right? As you go out to the right, it's heading downwards, so it would be negative infinity. That's all you have to think about, really. You don't need to memorize a bunch of different weird rules. Just think about what x is doing in the leading term. That's pretty straightforward. But just in case. How about the second one? Limit of p of x as x goes towards negative infinity on this expression. I'm still only concerned about the leading term.
So the leading term is x cubed or negative x cubed?
Leading term is negative x cubed now, in this example, negative x cubed.
And then you go in positive.
Negative.
Yeah, positive, that's right. Why positive? Because
The negatives cancel out.
the negatives cancel out. I got a super colossal negative number, right? Cubed. It's gonna be negative. Times the leading negative makes positive. Head towards positive infinity. That's correct. Right? It's better to think than to memorize rules. Or just think about what's going on in the problem. Any questions so far?
So what is the answer for this?
This one?
The limit f x.
Is this goes to negative infinity?
What is the answer?
Oh, good man. I totally skipped that, didn't I? We did that. We did half of the problem, didn't we? Is that what you're talking about?
Yeah.
Yeah, you caught me. Let's figure it out. What changes about the problem? So root of x squared plus 1 over 2x plus 1. So we played the same game. Factor off whatever we need to factor off. So that part looks familiar. Squared over 2 plus 1 over x. That's x. Yeah? That part's the same. Factor off the highest power from top and bottom. The x's cancel again. All right. So now, what is 1 over x squared heading towards as x goes towards negative infinity? Does the fact that it's heading towards negative infinity make a difference?
Yeah.
No, it still goes to 0.
Still goes to 0. Not only that, it goes to 0 and it's positive the whole time. Just not any bearing on the problem really, but I just want you to realize we have squares, right? It's still going to be positive. So this part here is heading towards 0. And what's this one heading towards? 0. Now, this one is positive the whole time. This one is negative the whole time. Is that correct? But the fact that this one's negative, since it's approaching 0, doesn't affect anything else that's going on over here because it's so ridiculously small. So even though now this one is negative the whole time, the 2, or whatever other number, whatever the constant number you would pick, is always going to outweigh it. Because this is infinitesimally small. And this is not. It's stuck at some fixed value. Right? So the bottom is still positive, and the top is still positive. So you have the exact same expression with the root of 1 over 2, which is 1/2.
So something weird because the fx, 2x plus 1 and x plus 1, the intuitively, the bottom is negative, and the up is positive. It should be something something there.
The bottom is always negative,